When working with Type 2C direct burial cable that lacks white or green conductors, it is essential to properly identify the grounded and grounding conductors. Several methods can be employed to achieve this, ensuring safe and compliant electrical connections. First option involves using electrical tape. For the grounded conductor, which serves as the neutral, wrap black electrical tape around the entire conductor, leaving approximately 3 inches of the end exposed. This provides a clear visual indication of its function. For the grounding conductor, wrap green electrical tape around the entire conductor. Green is the universally recognized color for grounding, making it easily identifiable. A second option involves utilizing heat shrink tubing. For the grounded conductor, use white heat shrink tubing to cover the entire conductor except for the last few inches. The white tubing clearly marks the neutral connection. For the grounding conductor, use green heat shrink tubing to cover the entire conductor, providing a durable and easily recognizable indicator. A third option includes the use of conductor markers. For the grounded conductor, use black conductor markers with the word neutral or the symbol N imprinted on them. These markers offer a professional and permanent labeling solution. For the grounding conductor, use green conductor markers with the word ground or the symbol G imprinted on them, clearly indicating its purpose. Regardless of the method chosen, it is crucial to label the ends of each conductor clearly to avoid confusion during installation or future maintenance. The black conductors should always be used for live circuits. The white or black conductor marked with white tape tubing or markers should be used for the neutral connection. The green conductor or the conductor marked with green tape tubing or markers should be used for grounding. Always adhere to all applicable electrical codes and regulations when using these cables to ensure safety and compliance. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations, including conductor identification. Some relevant sections of the NEC include Article 200, which covers the use and identification of grounded conductors, Article 250, which addresses grounding and bonding, and Article 310, which pertains to conductors for general wiring. Within Article 310, specific tables provide ampacity ratings for conductors based on their size, insulation type, and installation conditions. For instance, Table 310.16 provides ampacity values for insulated conductors rated up to 600 volts, not more than 3 conductors in a raceway or cable or earth, based on an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. Correction factors are also provided for ambient temperatures other than 30 degrees Celsius. When selecting conductors, it's important to consider the voltage drop. Voltage drop occurs when the voltage at the load is less than the voltage at the source due to the impedance of the conductors. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. Calculating voltage drop involves using Ohm's law and considering the length of the conductor, the current flowing through it, and the conductor's resistance. The formula for voltage drop is voltage drop equals current times resistance. The resistance of a conductor depends on its material, length, and cross-sectional area. The NEC provides tables that list the resistance of conductors in ohms per 1,000 feet. Grounding is a critical safety measure in electrical systems. It provides a low impedance path for fault current to return to the source, allowing overcurrent protection devices, such as circuit breakers or fuses, to quickly trip and energize the circuit. Grounding also helps to stabilize voltage and reduce electrical noise. The grounding system consists of a grounding electrode, such as a ground rod or a metal water pipe, connected to the equipment grounding conductors and the neutral conductor at the service entrance. Equipment grounding conductors provide a path for fault current from non-current carrying metal parts of electrical equipment to the grounding electrode. Bonding is the process of connecting all non-current carrying metal parts of electrical equipment together to create a low impedance path for fault current. Bonding helps to ensure that all metal parts are at the same potential, reducing the risk of electric shock. The NEC requires bonding of metal water pipes, metal gas pipes, and metal built-in frames to the grounding system. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Circuit breakers are resettable devices that trip when the current exceeds their rated value. Fuses are one-time devices that melt and open the circuit when the current exceeds their rated value. The NEC specifies the maximum overcurrent protection for different sizes and types of conductors. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electric shock. They monitor the current flowing in the hot and neutral conductors and trip the circuit if there's a difference of 5 mA or more. GFCIs are required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. Arc fault circuit interrupters, or RFCIs, are designed to protect against fires caused by arcing faults. Arcing faults occur when electricity jumps between two conductors, creating heat that can ignite nearby materials. RFCIs are required in many areas of the home, such as bedrooms and living rooms. When working with electrical systems, it is essential to follow safe work practices to prevent electric shock and other injuries. Always to energize a circuit before working on it by turning off the circuit breaker or removing the fuse. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. Never work on electrical systems when you are wet or standing in water. If you are not comfortable working with electrical systems, hire a qualified electrician. Electrical work can be dangerous and should only be performed by those who are properly trained and experienced. In addition to the NEC, local electrical codes may also apply. These codes may be more stringent than the NEC and may address specific local conditions. It is important to check with your local building department to determine which codes apply in your area. Proper conductor identification is crucial for maintaining a safe and reliable electrical system. By following the guidelines outlined in the NEC and using appropriate labeling methods, you can ensure that your electrical connections are properly grounded and grounded, reducing the risk of electrical shock and fire. Remember that electrical codes and regulations are constantly evolving, so it is important to stay up to date on the latest requirements. Consult with a qualified electrician or electrical inspector if you have any questions or concerns. In summary, when dealing with Type TC direct burial cable lacking white or green conductors, remember these key points. Firstly, utilize methods like electrical tape, heat shrink tubing, or conductor markers to clearly identify grounded and grounding conductors. Secondly, always label conductor ends to prevent confusion during installation and maintenance. Thirdly, ensure black conductors are used for live circuits, white or marked conductors for neutral, and green or marked conductors for grounding. Fourthly, adhere to all relevant electrical codes and regulations, including the NEC. Fifthly, consider factors such as voltage drop and conductor ampacity when selecting conductors. Sixthly, implement proper grounding and bonding techniques for safety. Seventhly, use appropriate overcurrent protection devices like circuit breakers and fuses. Eighthly, install GFCIs in high-risk areas and RFCIs for arc fault protection. Ninthly, follow safe work practices and use insulated tools and personal protective equipment. Tenthly, consult local electrical codes and seek professional assistance when needed. By adhering to these principles, you can confidently and safely work with Type TC cable, ensuring compliant and reliable electrical connections. Keep in mind that electrical work can be hazardous, and it is always best to err on the side of caution. If you are unsure about any aspect of the installation, consult with a qualified electrician. Remember to always double-check your work and test the circuits to ensure that they are functioning properly before energizing them. With careful planning, proper techniques, and a thorough understanding of electrical codes, you can safely and effectively use Type TC cable for a variety of electrical applications.